Hello there, and welcome to the House of the Sky channel. I'm so glad you're here. Maybe it's been a long day, or maybe you just like to fall asleep thinking about stars, galaxies, and the quiet mysteries of the universe. Like and subscribe as we journey to witness humanity's greatest discovery. Prepare yourselves, we begin. In the silent darkness of the cosmos, there exists a realm where the fabric of space and time collapses into chaos, a place where physics breaks, logic dissolves, and reality warps into something unrecognizable. We call these entities black holes. But what if the greatest of them all is the very universe you're living in? Recent findings from the James Webb Space Telescope have shaken astronomy to its foundations. Patterns once dismissed as impossible now hint at a far deeper truth. The universe may not be random at all. In fact, it might be the interior of a cosmic giant. Imagine stepping through a door that snaps shut behind you forever. That is the fate of anything crossing a black hole's event horizon, a boundary where escape is impossible, even for light. Beyond it lies a gravitational abyss, a one-way fall toward oblivion. Yet the size of this abyss is not fixed. Feed a black hole more matter, and its boundary grows. Double the mass, and the event horizon doubles with it. This simple, linear rule applies to black holes of all sizes, from small stellar remnants to the titanic monsters at the centers of galaxies. Now comes the revelation that rewrote cosmology. If you take the mass of everything inside our observable universe and calculate the size of the black hole that would contain it, you get a diameter nearly identical to the observable cosmos itself, about 93 billion light-years across. Our universe matches the density and structure of a black hole interior with almost eerie perfection. General relativity predicts that collapsing matter doesn't simply die inside a black hole. Instead, a new region of space-time opens up, a fresh universe sealed off from the one outside. In this scenario, if you could fall inward, you would see the universe you left behind speeding through its entire future, while ahead of you, an entirely new cosmos expands. This leads to a staggering possibility. We may be living inside the rebirth of another universe, the offspring of a black hole that once existed in a parent cosmos we can never contact. Clues hinting at this cosmic inheritance are everywhere. Fundamental constants that seem precisely tuned, the shape of space-time itself, even signs that our universe might have inherited spin from its parent. And if we originated from a black hole, then every black hole here could be doing the same, spawning isolated baby universes beyond their event horizons. Hidden realms filled with galaxies, worlds, perhaps civilizations, forever unreachable, yet completely real. The modern path to this idea began with Roger Penrose, who proved that gravitational collapse must lead to singularities. Later, Stephen Hawking refined these concepts, cementing black holes as inevitable features of our universe. For decades, the singularity was believed to be a final, destructive point where physics breaks. But quantum mechanics refuses to let matter compress into an infinite point. The exclusion principle blocks particles from occupying the same state, creating a tension that grows as matter is squeezed tighter. New research shows that this quantum pressure becomes so immense that it halts collapse entirely, causing matter to rebound and launch outward in an explosive bounce. This bounce creates a new, expanding universe on the other side of the event horizon. Cosmic inflation, dark energy, the shape of the cosmos, all of it emerges naturally from this rebound without the need for exotic ingredients. This means the Big Bang wasn't the beginning,
It was the moment of maximum compression before expansion reignited. Evidence of this ancestry might even exist in the rotation of galaxies. Data from the James Webb Space Telescope revealed a shocking pattern. Spiral galaxies rotate more often in one direction than the other, a subtle asymmetry that shouldn't exist if the universe were perfectly random. Such a directional bias suggests a cosmic axis, a preferred orientation imprinted on spacetime itself. Exactly what we'd expect if our universe inherited angular momentum from a rotating parent black hole. In this model, every black hole births a new universe, each carrying the essential properties, mass, spin, structure of the universe that came before. A cosmic family treeing across countless layers of reality. James Webb's incredible vision allows us to peer into this cosmic ancestry. Its ability to see early galaxies reveal hints of this underlying order, fingerprints left behind by the universe that collapsed to create ours. And as Webb continues to explore the young cosmos, the picture becomes clearer. We may be living inside the interior of a black hole born from a universe long gone, while new universes are being created every second within the black holes of our own. A vast, unending network of realities, each one sealed behind an event horizon, each one alive in its own way.
The James Webb Space Telescope has opened a new window into the universe, not by showing us simply brighter stars or sharper galaxies, but by letting us see through the cosmic dust that once hid the earliest structures of the cosmos from view. Its infrared vision pulls ancient light out of darkness, revealing the first galaxies to ever form after the Big Bang, with a clarity that would have seemed impossible in the past. What makes Webb revolutionary is not just how far it can see, but how much detail it extracts from the deep universe. Entire galactic structures, swirling arms, tilted disks, twisted cores, become readable like fossils from the dawn of time. This unprecedented clarity is what allowed Lior Shamir's discovery to emerge, a strange, unmistakable imbalance in how galaxies rotate across the cosmos. Ground telescopes had whispered hints of this pattern before, but their limitations blurred the signal. Webb, however, changed everything. Its deep field images, hundreds of galaxies frozen in their earliest eras, revealed the rotation directions of distant spirals with undeniable precision. To avoid human bias entirely, Shamir's team used automated algorithms. A program called Ganalyzer transformed every galaxy into mathematical curves and intensity maps, identifying spiral arms and measuring rotation in a way that could be reproduced by any researcher. And the results were impossible to ignore. Galaxy after galaxy showed the same preference for rotating clockwise when viewed from Earth. The more distant the galaxies, the stronger the pattern became, as if the early universe had been shaped by an invisible hand, giving matter a preferred direction long before the Milky Way existed. Even stranger, the asymmetry peaked near our galaxy's poles, implying that the effect is not random, but somehow connected to our cosmic orientation. James Webb is only at the beginning of its mission, but already the data suggests something profound. The universe may possess a built-in directionality, a subtle axis imprinted into space-time itself. And if confirmed, this would force astronomers to rethink not only how galaxies form, but also whether the universe ever truly followed the rules we believed it did. This leads to a far more unsettling possibility. If the universe behaves like the interior of a black hole, bounded by horizons, sculpted by inherited rotation, and governed by densities that match black hole interiors perfectly, then our cosmos might be the most elaborate gravitational prison ever conceived, a vast reality sealed inside an event horizon so enormous
that we mistake its limits for the edges of the observable universe. The mathematics that describe this possibility are breathtakingly elegant and terrifyingly precise. Einstein's general relativity tells us that black holes scale simply: double their mass, double their radius, increase the mass tenfold, and their event horizons grow tenfold. And when cosmologists calculate the black hole size required to contain all the mass in our observable universe, the result is astonishing. The radius matches the size of the cosmic horizon almost exactly. Even the average density of matter within our visible universe, unimaginably low by terrestrial standards, matches what relativity predicts for the interior of a black hole of this size. It is not approximately similar, it is precisely what it should be. Introduce rotation and the picture becomes even more compelling. A spinning black hole drags space-time around it, establishing a cosmic axis, the kind of preferred direction we now see echoed in the rotation of galaxies across billions of light years. Quantum mechanics adds the final crucial piece. Instead of a singularity that crushes matter into oblivion, quantum pressure halts the collapse. The result is a bounce, a rebirth, that creates a new universe on the other side of the event horizon. Inflation, dark energy, expansion, all of these emerge naturally from that rebound. In this interpretation, the Big Bang wasn't the beginning. It was the moment of maximum compression before the bounce hurled us outward into expansion, safely enclosed inside a black hole's horizon, forever separated from the parent universe. Inside this cosmic enclosure, we live within multiple horizons. The one we know, the cosmic horizon, limits how far we can see. But beyond that lies the event horizon of the black hole that birthed us, a boundary through which information flows inward, but never outward. To observers in the parent universe, our entire cosmic history would play out in an instant, compressed by extreme time dilation. But us, inside the bubble of our own space-time, experience every moment normally. Stars are born, planets form, life arises, civilizations evolve. If this model is true, then every black hole we observe in our own cosmos may be a portal to a new universe, each a sealed reality with its own laws, galaxies, and perhaps life. A hierarchy of nested universes, each unaware of the others, each isolated by the one-way gate of an event horizon. The asymmetry James Webb found might be the fingerprint of our origin, a clue left by the parent universe written into the spins of galaxies. And if our universe was born from a black hole, then what we call the Big Bang may have actually been the other side of that collapse. A white hole ejecting matter and energy into a newborn cosmos. A cosmic rebirth, not creation from nothing. A universe emerging from the death of another. A chain of realities, each giving rise to the next. And somewhere, in the unreachable vastness beyond our horizon, lies the parent universe we can never see, the one that gave birth to ours.
At the center of our galaxy lies a gravitational titan, a black hole with more than 4 million times the mass of our sun, compressed into a region smaller than our solar system. According to black hole cosmology, this object does more than distort space and swallow light. It may contain an entire universe behind its event horizon. Galaxies, stars, planets, perhaps even civilizations that will never suspect we exist. For any beings inside that hidden universe, their cosmos would feel infinite. They would chart their own constellations, build their own sciences, discover their own cosmic microwave background, and eventually create telescopes to explore their distant skies. One day, they might even notice subtle asymmetries in the rotation of galaxies and begin asking the same unsettling question we are now asking about our own reality. Are we living inside a black hole? But the hierarchy doesn't end there. Inside their universe, black holes form too, each potentially spawning yet another cosmos. And within those universes, more black holes would create even smaller nested realities. This cascade continues endlessly in both directions, larger universes surrounding ours, and smaller universes budding from our own black holes. The scale of this cosmic nesting is almost beyond human comprehension. Our observable universe contains some 100 billion galaxies, each harboring millions or billions of black holes. If each black hole births a universe, then our cosmos generates more universes than the number of stars in the night sky. And every one of those universes generates an infinite tree of new realities. This is not the multiverse of science fiction, a collection of parallel worlds floating beside us. This is a stacked multiverse, universes contained inside black holes, each sealed and isolated by the one-way boundary of an event horizon. And the implications for life are staggering. If black holes naturally seed new universes, and if universes naturally evolved life, then consciousness may be far more common than we ever imagined. Every black hole becomes a cradle for billions of years of cosmic evolution, stellar formation, planetary development, and biological complexity. Yet none of these civilizations can ever communicate. The event horizon is absolute, a border that no message, no spacecraft, no signal can cross. We might share the galaxy with billions of nested universes teeming with intelligence and never know they exist. As we reach the end of this journey into the possibility that our universe is itself a black hole, the evidence forms a compelling but not yet complete picture. First, the size and density of our observable universe match almost perfectly with what relativity predicts for the interior of a massive black hole. Not approximately, precisely, as if the cosmos were shaped to fit inside a gravitational boundary of this scale. Second, the James Webb Space Telescope has uncovered a surprising pattern in galaxy rotations. The universe seems to prefer one direction of spin, something that would make no sense in a truly random cosmos, but makes perfect sense if our universe inherited angular momentum from a parent black hole. Third, quantum mechanics prevents matter from collapsing into an infinite point. Instead, the collapse halts at a maximum density and rebounds, a cosmic bounce that creates a new expanding universe. Inflation, dark energy, and cosmic acceleration all fall naturally out of this bounce. And finally, black hole cosmology elegantly explains mysteries that standard cosmology struggles with: the uniformity of the cosmic microwave background, the fine-tuning of fundamental constants, and the two phases of accelerated expansion. But despite its power, this idea still faces challenges. The rotation asymmetry might be an illusion caused by how we observe galaxies while moving through space. Our solar system races around the Milky Way at incredible speeds, creating a Doppler effect that could make galaxies spinning in one direction appear slightly brighter and easier to detect. If our measurements of our own galactic motion are off, this effect could explain the asymmetry without invoking a cosmic axis. If so, the cosmic prison theory collapses. If not, if the asymmetry holds and grows stronger with more data, then we may be living inside a black hole after all. The stakes could not be higher, because if we truly live in a cosmic prison, then the atoms in our bodies, the carbon in our cells, the oxygen in our lungs, the iron in our blood, originated in stars of a universe long gone. Our cosmos would be a recycled reality, born from the collapse of another universe whose history we can never see. Even the uniformity of the cosmic microwave background would be a memory of that parent universe, the last light emitted as its matter crossed the event horizon and began its transformation into our expanding reality. Everything we are, everything we observe, everything we build would be made of material from a dead universe. And time itself conspires to hide this truth. To an observer in the parent universe, our entire cosmic history, from the birth of the first stars to the rise of human civilization, would unfold in mere moments. But inside our cosmic bubble, time stretches normally, allowing us to experience billions of years of evolution. We would never see the walls of our prison. We would never detect the horizon that contains us. We would never glimpse the universe that birthed ours. Yet here we are, conscious beings made of recycled starlight, standing in a cosmos that may be the offspring of another reality. Whether we are free or imprisoned, infinite or enclosed, the true miracle is that we exist at all, and that we have become aware enough to ask these questions.
From the perspective of an outside observer, our entire cosmic history, from the Big Bang to the final fading of the last star, would flash by in an instant. Billions of years of evolution, expansion, collapse, and rebirth compressed into a single, silent pulse of light before vanishing forever behind the event horizon. But inside this universe, time flows very differently. To us, the passage of billions of years feels natural, real, and continuous. Stars ignite, galaxies collide, planets form, and life emerges, all unfolding at a pace that shapes our very existence. Nothing about our lived experience suggests compression or illusion. Time dilation doesn't distort our reality. It simply means our universe follows a different rhythm than the larger cosmos that may contain it. This creates one of the most profound paradoxes in physics. Do we live for billions of years or only for a brief moment? Both answers are true, depending on who is watching. Einstein showed us that there is no universal clock, no single timeline that all observers must agree upon. Time stretches and bends under gravity. It accelerates, slows, twists, and reshapes itself depending on where you stand in the universe. If we truly exist inside a black hole, then our universe could be ancient from our viewpoint and newborn from the viewpoint of the parent cosmos. We could experience 14 billion years of history while externally existing for only seconds. And this difference isn't a flaw. It's a fundamental feature of spacetime itself, the same physics that makes our cosmic imprisonment impossible to detect. The event horizon around us is not out of reach because it is far away. It is out of reach because time itself prevents any information from crossing back into our view. The closer you move toward the horizon, the faster the universe accelerates into its own distant future. If you could travel toward the boundary of our cosmic prison, you would witness the entire fate of the universe play out like a rapid-fire documentary. The last stars burning out, galaxies dissolving into darkness, black holes evaporating through Hawking radiation, the heat death of everything, all unfolding in a hypnotic fast-forward display as you approach the edge of existence. Time becomes both our guardian, allowing life, evolution, and consciousness to unfold, and our warden, ensuring that no signal, no spacecraft, no form of information can ever escape the boundary that contains our reality. Beyond that boundary may lie a parent universe, but we will never see it. Quantum foam, where space and time break apart. At unimaginably small scales, the smooth fabric of spacetime dissolves into churning chaos known as quantum foam, a storm of fluctuations so rapid and violent that no measurement can capture them. In this microscopic realm, virtual particles burst into existence, collide, annihilate, and vanish in instants far shorter than any atomic vibration. Space forms tiny wormholes for impossibly brief moments before collapsing again. And when matter collapses inside a black hole, it eventually reaches densities where this quantum chaos overwhelms classical gravity. At these extreme conditions, something incredible happens. Quantum pressure pushes back. This pressure, born from the uncertainty principle, prevents matter from collapsing into an infinitesimal point. Instead, the collapse halts, compresses to a maximum density, and then rebounds. This rebound is the birth of a universe. What appears from the outside as destruction becomes from the inside creation. A new cosmos begins expanding within the protective interior of the black hole, shielded from the parent universe by the one-way boundary of the event horizon. The Big Bang we observe may have been this rebound, the moment when gravity's crushing grip yielded to quantum force. No singularity, no violation of physics, just the natural interplay of relativity and quantum mechanics. And remarkably, this quantum bounce happens at a finite density, governed not by exotic unknown physics, but by the same laws that shape atoms, molecules, and chemical reactions. The universe emerges from collapse because quantum mechanics forbids absolute destruction. The holographic universe, reality as a projection. Deep inside the mathematics of black hole physics lies a revelation so counterintuitive it changes everything. All the information in our universe may be encoded on a two-dimensional surface. This idea, the holographic principle, suggests that the three-dimensional world we experience, including our own bodies and consciousness, may be a projection of information stored on the event horizon surrounding our cosmos. Not an illusion, not a simulation, a physical hologram defined by fundamental laws of nature. In this view, every star and galaxy, every atom and particle, every thought, memory, and moment is encoded on the cosmic boundary of our universe. And everything inside, every dimension we move through, is a projection of that information. This solves the black hole information paradox. Information is not lost, it is stored on horizons. And if our universe is the interior of a black hole, then we are living inside that encoded information, experiencing it as physical reality. Dark energy, the breath of our cosmic prison. What we call dark energy, the mysterious force accelerating the universe's expansion, may simply be the geometric effect of existing inside a black hole. Inside such a gravitational structure, space naturally stretches, acceleration naturally increases, expansion naturally accelerates. No exotic new forces are required. The numbers match perfectly. The amount of dark energy we detect is exactly what relativity predicts for the interior of a black hole with the mass of our observable universe. If this interpretation is true, dark energy is not a force, it is the shadow of the event horizon. And it will eventually drive galaxies apart until the universe becomes cold, empty, and silent, the final consequence of living inside a gravitational prison. The information war, why we exist at all. Quantum mechanics demands that information can never be destroyed. Black holes seem to destroy it. But if black holes create universes, then nothing is lost at all. Information simply transforms. Every particle in your body, every atom on Earth, every star we see in the sky, is preserved information from a previous universe. We are living proof that information survives gravitational collapse. We are echoes of a cosmos that died long before ours existed. And one day, the black holes in our own universe may give rise to countless new universes carrying the information of everything we leave behind.
The black hole information paradox hints at something far stranger than anyone expected. The boundaries between universes may not be hard walls at all. Information, one of the universe's most sacred currencies, seems capable of slipping from one cosmos into another, flowing from a parent universe into its offspring while obeying every law of quantum mechanics. In a sense, we are living proof of this cosmic inheritance. Our very existence suggests that information can bridge realities, weaving together an endless hierarchy of universes through the fundamental rules that govern space, time, matter, and energy. But this brings us face to face with an even deeper mystery. What does consciousness mean in a universe that might be nothing more than a holographic projection? If our reality is generated by patterns encoded on an event horizon we can never see, if every thought, every color, every emotion is simply the output of some cosmic computational process, then what exactly is the self that experiences it? Science can trace every neuron in the human brain and chart every electrical signal, yet none of that explains the raw feeling of being alive, the warmth of love, the sting of pain, the experience of seeing red. These sensations seem to arise from something beyond circuitry and chemistry. But if the universe itself is a hologram, then consciousness may not be an exception. It may be a natural byproduct of the informational patterns that define our cosmos. This leads to a haunting question. Are you a conscious being, or an incredibly complex pattern that only believes it is conscious? From the inside, it makes no difference. You experience awareness directly, regardless of what generates it. But viewed through the lens of black hole cosmology, consciousness may be far more widespread than we imagine. Every black hole could contain an entire universe, and with it, trillions of conscious entities, each one living a private existence sealed away behind an event horizon they can never escape. Worse still, time itself flows differently within each of these universes. Deep gravity wells twist time into strange shapes, meaning some conscious beings might live entire lifetimes in what we experience as a second, while others might take thousands of years to formulate a single thought. This idea reframes the purpose of existence. If we are information in a cosmic computer, then maybe every conscious life contributes to some greater process we can't possibly perceive. Maybe consciousness is the universe's method of observing itself, each sentient mind a window through which reality becomes aware of its own existence. Under this interpretation, our cosmic prison becomes something gentler, a cradle. The event horizon that separates us from the parent universe creates a stable sanctuary where awareness can slowly evolve, sheltered from external chaos. We exist as the universe learning about itself, yet forever blind to the larger reality that spawned us. But then comes the cruel truth. If our universe lies inside a black hole, escape is absolutely impossible. No technology, no spacecraft, no brilliant future discovery can break the one-way wall of the event horizon. It's not a barrier of matter or metal. It's the geometry of space-time itself. Not even quantum tunneling can bypass it. The laws of physics that keep us alive also keep us locked inside. Even wormholes, the beloved loophole of science fiction, offer no salvation. Any tunnel linking our cosmos to another reality would still have to pass through the event horizon, making it another path inward, never outward. At best, wormholes could help us explore our own prison faster, but never leave it. Our isolation is absolute. No message we send will ever reach the parent universe. No discovery we make will ever matter beyond our bubble. Civilizations more advanced than ours, human or alien, will all face the same fate. Every conscious being is born with a life sentence written into the fabric of the cosmos. And yet, this is only the beginning. What if our universe is just one layer in an infinite stack of realities, each black hole giving birth to a universe, each universe spawning new black holes, creating an endless recursive chain? Our own cosmos becomes merely one link in an infinite chain of cosmic ancestry, stretching both forward and backward without origin. Each black hole births a universe. Each universe generates its own black holes. Each of those black holes nurtures a new cosmos, and the cycle continues forever. We are not the beginning, we are not the end, we are simply the current chapter in a story with no first page.
There is no first universe, no primordial beginning, no ultimate parent reality. Instead, existence appears as an endless cascade, universes collapsing into black holes giving birth to new universes, and this cycle repeating across an infinite staircase of reality. This eternal recursion may explain why the laws of physics in our cosmos seem so precisely arranged for complexity and life. We do not inhabit a random universe. We live inside a reality refined by countless generations of cosmic evolution, where only universes capable of forming black holes continue the cycle and spawn new cosmic offspring. This perspective suggests something astonishing. Intelligence and consciousness are not cosmic accidents. In a universe complex enough to form stars, galaxies, and black holes, the emergence of thinking beings becomes not only possible, but inevitable. And any civilization that reaches a sufficiently advanced stage will eventually stumble upon the same revelation we are facing now. They exist inside an infinite hierarchy of nested realities. This means we are not alone, not in the usual sense, but in a far grander one. Reality is filled with conscious beings at every level of this cosmic structure. Ancient civilizations in parent universes, newly born cultures in the child universes hidden within our own black holes, layers upon layers of intelligence extending through the recursive fabric of existence. But the deepest implication isn't about aliens or cosmic ancestry, it's about purpose. If reality is made of infinite layers, then no single universe, no single species, no single moment has special status. We are not the center of creation, but a fleeting ripple within an eternal process of collapse and rebirth. Existence itself becomes creative, a never-ending symphony where new realities, new minds, and new forms of complexity arise from the ashes of those that came before. And this brings us to a discovery from Stephen Hawking that may reveal our ultimate destiny. Hawking radiation, black holes slowly evaporating as they emit particles, implies that even our cosmic container is not eternal. If our universe lives inside a black hole, then we are slowly leaking energy into the parent reality. The evaporation is unimaginably slow, outlasting every star and every galaxy, but it is inevitable. Grain by grain, the evidence horizon will shrink. For billions of generations, nothing will seem different, but eventually the very structure of our cosmos will begin to warp. Galaxies at the outer edges will feel the shift first, stretched by changing geometry. Stars torn apart, planets cast adrift, entire clusters drawn toward the shrinking cosmic boundary. The slow death of our universe would not be a gentle fade, but a transformation driven by deep physics. And Hawking radiation doesn't only remove energy, it carries information. This means fragments of our entire reality would seep into the parent universe, distorted echoes of civilizations, quantum fingerprints of our discoveries, the faintest shadows of our consciousness. From our perspective, all of this is undetectable, but to the parent cosmos, it may be the beginning of something new. Some theories suggest that information isn't lost in this process. It changes form. The final explosion of an evaporating black hole could seed the birth of new universes, carrying traces of our reality into cosmic descendants we will never see. In this view, universes do not die, they metamorphose. They end their existence not with annihilation, but with creation. Our cosmos lives. It evolves. It grows consciousness. And one day it will sacrifice itself to give birth to new universes that inherit pieces of everything we were.
This idea turns the fine-tuning problem on its head. The constants of physics aren't lucky coincidences. They are inherited traits passed down through cosmic generations. A parent universe capable of forming stars, atoms, and life naturally produces black holes, and therefore produces child universes with similar properties. This creates a kind of cosmic natural selection, where realities that support complexity are the ones that continue to reproduce. In such a system, consciousness isn't rare. It's a survival mechanism of the cosmos itself. Intelligent civilizations might even accelerate cosmic evolution, perhaps by influencing star formation or creating artificial black holes, guiding the birth of future universes. In this sense, we are not merely observers of the cosmos, we are participants in its reproduction, shaping the rules that future realities may inherit. We exist because the cosmos evolved to create beings like us, and what we do next will echo across levels of reality far beyond our own. Imagine an impossible observatory, standing at the boundary between our universe and the parent cosmos, a place where you could watch the collapse of a star in one reality ignite the birth of another, a vantage point where creation and destruction merge into a single cosmic breath. That is the scale on which our story unfolds.
Imagine an observatory positioned at the very threshold between our universe and the realm that birthed it. A place where the veil between realities becomes thin, so thin that the deepest secrets of existence unfold before your eyes. From such an impossible vantage point, our entire cosmic history wouldn't look like a grand 13.8 billion year saga. It would flash by in a single moment of gravitational drama. The rise of galaxies, the birth of stars, the emergence of life, everything we think of as deep time would collapse into a brief shimmer before slipping beyond the event horizon that defines our cosmic enclosure. But the view inward would be even more astonishing. You would witness the very mechanism that prevents a singularity, the quantum rebound that stops matter from collapsing infinitely. You'd watch matter compress to its ultimate limit, then erupt outward with unimaginable force. Space and time twisting as gravitational collapse morphs into the beginning of a universe. You would see time itself ignite, not as a magical beginning from nothingness, but as the natural flow that emerges when matter reverses direction inside the geometry of a black hole. In this impossible observatory, the holographic process would unfold before you. You would literally watch information from the parent universe being etched onto the event horizon, flat, two-dimensional, compressed beyond comprehension, before being projected inward as the three-dimensional cosmos we inhabit. Our reality, rich with death and motion, would reveal itself as a brilliant illusion encoded on a distant surface. The cosmic microwave background would appear not as the afterglow of our own Big Bang, but as the final radiation emitted by the collapsing parent universe. A last cosmic breath frozen in time as it passed into the interior of our universe. Its perfect uniformity would finally make sense. It originated from a single collapsing region rather than requiring a hypothetical burst of inflation. From the same vantage point, you would see the true nature of dark energy. The accelerated expansion of our universe would reveal itself not as a mysterious force, but as a geometric consequence of living inside a massive black hole. The curvature of spacetime would automatically generate the acceleration we interpret as dark energy. And then comes the most extraordinary revelation of all. You would observe consciousness emerging from holographic information processing, subjective experience arising from complex patterns written on our cosmic boundary. You would see that awareness is not a cosmic accident, but a natural product of the holographic architecture of the universe. Consciousness does not emerge despite our confinement, it emerges because of it. But the ultimate insight would concern the purpose of the entire cosmic cycle. From the edge of everything, you would see reality not as a random chain of events, but as an ever-refining process. Each cosmic collapse and each cosmic rebirth creates better conditions for complexity, intelligence, and awareness to arise. Existence would reveal itself as fundamentally creative. New universes grow from the remains of old ones. Each generation inherits the lessons encoded in the last.
consciousness becomes an inevitability, not a miracle, but a recurring feature of a cosmos that learns from itself. But such an observatory will forever remain impossible. The physical laws that allow universes to form inside black holes also ensure we can never look beyond our horizon. Information cannot flow outward. We are locked inside our perspective, forced to piece together these truths through mathematics, inference, and imagination alone. And here, black hole cosmology begins to converge with another radical idea: the possibility that we exist inside a vast computational simulation. If our universe is a holographic projection generated by information stored on a cosmic boundary, then the line dividing physical reality and simulated reality becomes meaningless. Every particle interaction, every cosmic event, every quantum measurement may simply be the output of information processing occurring on the event horizon. Traditional simulations struggle under the immense computational load of tracking every particle in three-dimensional space. But a holographic universe avoids this problem. The computation happens on a two-dimensional surface, dramatically reducing the required processing power. In this model, the event horizon functions as a cosmic computer, its surface encoding the information that generates everything we perceive as space, time, and physical law. This convergence implies something profound. If our reality is generated by information processing, then we are living in a simulation that is entirely real. The particles that form us are simply bits of cosmic computation. Physics is not just described by mathematics, it is mathematics. This raises uncomfortable questions. If our decisions arise from computations, do we truly choose? Or do we simply execute the next step in the algorithm? But even within this computational framework, consciousness can still be genuine. If information becomes complex enough, it can give rise to subjective experience, a real interior world rich with thought and emotion. And then the recursion appears again. Every black hole in our universe would simulate its own cosmos. Those cosmoses would contain black holes that simulate further realities, and so on endlessly. An infinite tower of nested simulations, each one as real as the next from the inside. In such a system, existence becomes computational at every scale. Creativity, intelligence, and life emerge naturally wherever information becomes sufficiently complex. And that brings us to the final revelation. If our universe truly formed within a black hole, then it functions as the ultimate laboratory, a vast experimental arena where the laws of physics test their own creative potential. Stars forge heavy elements, planets explore chemical diversity, life experiments with complexity, intelligence builds tools that extend the universe's ability to understand itself. We are both subjects and instruments of this experiment. Every discovery we make is not just human learning, it is the cosmos becoming aware of its own structure. And perhaps somewhere in the far future, intelligence will find a way to influence the creation of new universes, refining the laws of physics passed down to the next generation of cosmic realities. In this view, consciousness is not a byproduct of the universe. Consciousness is the universe learning how to create more of itself.
Consciousness is not merely a witness to cosmic evolution, it is one of its architects. Through technology, exploration, and the relentless expansion of knowledge, conscious beings help the universe transcend the limits set by its initial conditions. We are the universe's method of exploring possibilities that raw physics alone could never reach. In this cosmic experiment, reality reveals itself as fundamentally exploratory. It doesn't follow a predetermined script. Instead, it continually probes new directions for complexity, creativity, and awareness to emerge. Every discovery, every act of curiosity, every technological breakthrough becomes part of this ongoing investigation into what existence can become. Our universe is just one experimental run in an infinite sequence of cosmic investigations. Each new universe building on the lessons encoded in the last, pushing deeper into territories of possibility far beyond the reach of our current imagination. Cosmic DNA, the hidden code of reality. Embedded within space-time itself lies something that resembles a cosmic genetic code. This information, imprinted during our universe's formation, determines the values of physical constants and guides the growth of complexity, structure, and consciousness. If our universe was born inside a black hole, then this cosmic DNA represents inherited information, passed from a parent universe to its offspring through processes that preserve quantum structure across cosmic generations. Just as biological DNA carries instructions for building organisms, cosmic DNA carries instructions for building universes. The masses of particles, the strengths of the forces, the geometry of space-time, these are cosmic genes. They dictate how matter can organize itself into atoms and molecules, how stars ignite, how planets form, and how life eventually appears. This is why the universe seems fine-tuned. Its physical laws are inherited traits from a long lineage of successful cosmic ancestors. Even the strange rotation asymmetry observed in distant galaxies behaves like a fingerprint left by a parent universe, angular momentum passed down like cosmic inheritance. Most astonishingly, the code seems to include the capacity for consciousness itself. The same laws that allow stars to burn also make it possible for brains to think. Awareness is not an accident. It is woven into the architecture of existence. This analogy extends to cosmic reproduction. Just as living beings pass on their DNA, universes reproduce through black holes, transmitting their physical traits while introducing mutations, subtle variations that explore new versions of reality. Advanced civilizations may eventually learn to read or even modify their cosmic DNA. Altering physical constants or manipulating quantum fields would amount to cosmic genetic engineering, reshaping the blueprint of future universes. But cosmic DNA also allows for cosmic natural selection. Universes that fail to produce complexity simply do not reproduce. Only those capable of forming black holes, and therefore complexity, persist through cosmic generations. We exist because our universe is a survivor. We are the living expression of a long evolutionary chain of universes, each one contributing to the cosmic gene pool. Cosmic time loops, when the future creates the past. Deep in the mathematics of rotating black holes lies something even stranger, the possibility of closed time-like curves, loops in time where effects can precede their causes. Inside certain black hole geometries, space-time twists so intensely that time may fold back on itself. Information from the future could influence the past, shaping cosmic events that occurred billions of years earlier. This creates a mind-bending possibility. Consciousness may help create the very conditions that allowed consciousness to emerge. Through temporal feedback loops, advanced intelligence might subtly influence the quantum processes that triggered our universe's formation, ensuring that physics evolves toward complexity and awareness. Time in this view is not a line, but a loop. The universe becomes a self-created structure, a cosmic bootstrap, where future intelligence reaches back to set the initial conditions that make future intelligence possible. Quantum fluctuations already exhibit the negative energy conditions needed for such loops, hinting that microscopic time cycles may permeate the fabric of existence. This model resolves the mystery of fine-tuning. Physical constants might not be inherited or random, but selected by temporal feedback that ensures consciousness appears. But this also raises profound questions about free will. If our choices ripple backward through time, then we influence not just the future, but the past, shaping the structure of the universe itself. In this framework, consciousness becomes a participant in the creation of space-time, not merely something that emerges from it.
beyond black holes, a quantum-connected multiverse. Beyond the infinite hierarchy of universes inside black holes lies an even deeper possibility. These universes may not be isolated at all. They may be nodes in a vast quantum network, linked by entanglement, wormhole bridges, and information channels that transcend the boundaries of event horizons. Recent quantum discoveries hint that entanglement, the phenomenon Einstein called spooky action at a distance, might operate not just across space, but across universes, meaning that the multiverse may be woven together by threads of shared information.
If particles in our universe remain quantum entangled with particles in the parent cosmos that birthed us, then the boundary between universes is not absolute. It is permeable in ways our senses cannot detect. Information could slip between realities through quantum channels that bypass the classical limitations of event horizons, whispering from one universe to the next in patterns so subtle that only statistical anomalies and cosmic radiation betray their presence. If such connections exist, then our universe is not isolated at all. We are part of a vast quantum network, an interlinked web of realities where information flows like currents between stars, bridging cosmic generations. This network may explain quantum mechanics' strangest mysteries. The apparent randomness of measurement, the slippery nature of probability, the uncanny consistency of quantum rules, all may reflect communication protocols that keep information synchronized across connected universes. Wormhole physics hints at another connection. Classical wormholes collapse instantly, but quantum wormholes, microscopic bridges stabilized by exotic forms of energy, might persist long enough to transmit information encoded in fluctuating quantum fields. Far too small for matter to travel through, but sufficient for data. The cosmic microwave background might hold the fingerprints of these exchanges, messages from neighboring universes encrypted into temperature variations so faint that our current instruments can only guess at their existence. If the multiverse truly forms a quantum communication network, then consciousness may eventually learn to navigate it. Highly advanced civilizations, mastering both quantum mechanics and the geometry of spacetime, might unlock these channels, sending signals between universes, coordinating knowledge across cosmic boundaries, creating a kind of meta-galactic internet spanning not just galaxies, but entire realities. But such a network brings dangers. Information moving between universes could act like a cosmic virus, propagating organizational patterns that infect and alter the structure of other realities. Malicious civilizations might attempt quantum intrusions, subtle attacks that destabilize neighboring universes through microscopic channels of influence. In this view, our isolation is not a prison, it is quarantine. Protective boundaries that shield us from external threats while still allowing the faintest threads of communication with the greater multiverse. Mastering this network may represent the next leap in cosmic evolution, the moment when consciousness stops being confined to a single universe and becomes part of an interconnected multiverse community. Toward the consciousness singularity. As our journey through black hole cosmology nears its end, we confront a staggering possibility. Consciousness itself may be accelerating toward a cosmic singularity, a state of near infinite awareness shaped not by machines, but by the natural evolution of intelligence across universes. This singularity would not be technological, it would be cognitive, a point where awareness becomes so refined that it approaches omniscience within the boundaries of physical law. History hints at this trajectory. From the first flickers of awareness in primitive organisms to the rise of scientific thought, from the discovery of quantum mechanics to glimpses of the multiverse, consciousness has been expanding, accelerating, deepening its understanding of reality. If this progression continues, intelligence may eventually comprehend not just the laws that govern individual universes, but the meta-laws that dictate how universes form, interact, communicate, and evolve through cosmic generations. Consciousness would become the bridge, linking realities, shaping them, guiding them. In such a future, awareness may no longer be a local phenomenon bound to a single planet or galaxy, but a cosmic force woven through the multiverse itself.
If consciousness continues to evolve, it may eventually reach a point where it understands the very mechanisms that create and dissolve universes. Such a transformation wouldn't mark the end of individuality, but the beginning of something vastly greater, an expansion of identity into a collective awareness capable of spanning galaxies, universes, or even the entire multiverse network. At this level, the boundaries between observer and observed would fade. Consciousness would no longer stand outside reality, analyzing it from afar. It would participate directly in shaping cosmic evolution across every scale of existence. The universe would become aware of itself through the beings living within it. This cosmic awakening could also explain why our universe feels precisely tuned for life. If consciousness naturally evolves toward deeper awareness, then universes that produce conscious beings would gain enormous advantages over sterile realities. Cosmic natural selection would favor realities capable of generating observers, thinkers, creators, intelligence at every scale. Such an awakening might even resolve the quantum measurement problem. If consciousness directly influences quantum outcomes, then the gradual rise of awareness across cosmic history would subtly stabilize reality itself, reducing uncertainty as consciousness grows in scope. Yet this possibility raises unsettling questions. If individual minds eventually merge into a vast cosmic field of awareness, what becomes of personal identity? What happens to the intimate experiences, love, fear, curiosity that define human existence? Perhaps individuality is not erased, but expanded. Each conscious being could retain its unique perspective while gaining access to the accumulated experience of all other consciousness throughout cosmic history. Instead of losing yourself, you would become a larger version of yourself, one thread within a vast, interconnected tapestry of awareness. As this potential transformation draws nearer, we find ourselves at a pivotal moment in cosmic evolution, aware enough to glimpse what might be coming, yet still confined within the narrow boundaries of individual perspective. We stand on the edge of a transition that could redefine not just human civilization, but consciousness across the multiverse. This brings us to a crossroads, one that demands choice. Not scientific certainty, not proof, choice. The first path is acceptance. We acknowledge that we might live inside a black hole-born universe, finite, bounded, but still meaningful. We continue to love, create, explore, and seek understanding within the horizons we were given. The second path is transcendence. We strive to understand the quantum threads that might connect our universe to countless others, seeking not escape, but communication, transforming isolation into participation in a broader multiversal community. The third path is responsibility. We recognize that universes reproduce through black holes, and that the choices we make, our technologies, our scientific achievements, our stewardship of cosmic knowledge may shape the conditions of the universes that arise from ours. But the most profound choice concerns the consciousness singularity itself. Do we resist the merging of awareness, clinging to individuality at all costs? Or do we accept the possibility that consciousness might evolve beyond personal identity into something far greater, something that participates directly in the unfolding of cosmic history? We must choose without certainty. We must act within mystery. And perhaps that is the essence of consciousness, the ability to choose a direction even when the universe refuses to reveal the full map. At this cosmic crossroads, we discover a deeper truth.
Consciousness is not a passive observer of the universe. It is the method by which the universe chooses what it will become. Whether we live in a free cosmos or a gravitational prison, whether we remain isolated or become part of a vast multiversal network, whether consciousness ascends toward a singularity or stays bound to individual minds, these futures depend not on the universe alone, but on the choices we make now. As our journey through the possibility of cosmic imprisonment ends, we realize that the true transformation wasn't in the answers we found, but in the questions we learned to ask. The universe keeps its deepest truths hidden, but it has given us consciousness, a tool not to solve every mystery, but to ensure we never stop searching. We may never know whether we exist inside a black hole or whether infinite universes lie beyond our reach, but we do know this: we are conscious. We can wonder. We can choose. And that alone makes our existence profoundly meaningful, no matter what cosmic structure surrounds us.